All right, so we're going to do a little review of the basic trigonometry from geometry class before we head into regular trigonometry. So, just a couple little reminders. Remember that trigonometry is in geometry for right triangles only. We'll use it for some that aren't right triangles in this class, but in geometry, it's basically just a right triangles only deal. And what trigonometry does is it relates sides and angles. Where the Pythagorean theorem is used only for sides. The angles don't matter in the Pythagorean theorem, but in trig, they are kind of the most important piece. When you are looking at a right triangle in trig, there's a couple vocabulary words that are super important and some things that are important as far as how you look at the triangle. So actually, let's label these sides or these angles A, B, C. All right. So here is a right triangle. If we knew two sides, we could figure out the third side, or at this point, we'll be able to figure out an angle. So if I am kind of looking over here at angle A, that's kind of your home base. And from there, you're going to decide names for the other sides that you're going to use to decide which trig function to use. Always, the side across from the right angle is the hypotenuse. But then we have words, and you might remember them, opposite and adjacent. Well, opposite is when you're kind of standing on this angle looking across. That's opposite. So another person said that if you put your pen like pointing at the angle that you're thinking about, the side it's pointing to is the opposite side. The adjacent side is the other side that's right next to it. But you can see that if I switch angles, so now I'm focused over here on angle B, the hypotenuse is still the hypotenuse, always across from the right angle. But now my pen is pointing to the other side as opposite and adjacent is right next to it. And that's really one of the most confusing parts of basic trig for people is to kind of pick out which one is opposite and adjacent. Another kind of important thing that you just want to keep in mind, we often use like a theta. Some people draw it like that or like that. That's a variable we use for angles. But we can use other Greek letters or X or Y or whatever. It doesn't matter what we use, but we can. But a lot of times you'll see one of these guys or something weird, and all it really is a another variable. All right, and another quick reminder: at this point, right now, you want to be sure your calculator is in degrees. We are going to learn about that other mode, the radian modes, this semester, but for right now, we're going to be in degree mode. So let me show you how to do that. If you are on a Desmos calculator, you go over here to settings, and you can see at the bottom where you can just click degrees. So that's in Desmos. If you are using a graphing calculator, it's under mode. And if you go down a little bit, you'll see radians and degrees. Just press enter on degrees. Your phone calculators also have degree mode. You just click right there. See, it says radians, and you click degrees. Okay, so it works on all devices. And the last thing on this page, I just want you to write this, and hopefully it brings back memories. So, door. All right, and that is the little word that we all kind of use to remember that sine is opposite and hypotenuse, adjacent, or cosine is adjacent hypotenuse, and tangent is opposite and adjacent. All right, so what we're going to do on the other side is review the three basic trig functions that you already know or have learned at least. All right, so we have sine, cosine, and tangent. And all three of these trig functions work the same way. The solving of the equations is identical. The only difference is which sides we're using. All right, let me back up just a little bit more so we can hopefully get all the pictures in here. All right, so as far as equations go, the sine equation is sine theta, or a variable, is equal to the opposite side over the hypotenuse. A couple things that are important to remember. This is the angle measurement. So let's say angle measurement. But the whole piece, sine theta, this is a number. So when you're solving equations with these, you can't really break apart the sine and the angle measurement. Unless the only time is when you're looking for an angle, but you can't just divide by sine. These go together to create one particular number. So don't break them apart except for the angle situation. Okay? Cosine, cosine theta, and this time it's the adjacent side over the hypotenuse. And same thing. This is the angle, this is a number. And tangent, tangent theta is opposite over adjacent. So let's look at what that looks like diagram style. And I'm actually going to put numbers on these diagrams instead of making them generic diagrams, just so you can look at how they look different. And then each one I'm going to use as an example of something else. So for example, this first problem, well, I'll kind of write that in as we go. I think that'll make more sense. So for this first problem, I'm just going to fill in some numbers so you can see how this works. All right, so here are three diagrams, and we're just going to kind of talk through how we use the formulas and what the situations are. So the first thing that you want to do with any diagram that you get is identify if it's sine, cosine, or tangent. The way you do that is you start with the given angle or an angle that has some amount of information inside of it. So for each of these, we're going to be focused on the angle. And then we're going to decide sine, cosine, or tangent. Well, this is the hypotenuse across from the right angle. And this side, if we're pointing, remember, you can kind of look across and see the 14, opposite. This side is the adjacent side, but there's no information there, so it's not super helpful. Let's look at the next one. From here, we have our angle. This side is opposite. This is the hypotenuse. And right here, right next to it, is the adjacent side. And lastly, same thing, opposite, hypotenuse, adjacent. That's the hardest part for people to figure out. So if you're struggling with that, let me know and I'll work with you on it. After that, we need to decide, are we talking about sine, cosine, or tangent? Some problems could actually be any of them, depending on what they give you. So you just have to kind of pick the one that you are willing to work with. For this first one, theta is what we're looking for. So this is going to be example of how to find angles, okay? And this method will work regardless of the trig function. All right, so we have information on our opposite side and our hypotenuse, so we're going to use sine. Sine theta, because we don't know what it is, equals the opposite side over the hypotenuse. Whereas this one, we're given information on the adjacent side and the hypotenuse. And you can also kind of compare. We have information on the same two sides, but where our angle is matters. All right, so this one we have adjacent and hypotenuse. So this one's going to be cosine the angle equals adjacent over hypotenuse. For this one, we're looking for a side, and x is on the bottom. So that's going to be what this problem is illustrating. How do you solve it when the x is on the bottom? And the last one, we don't have information on our hypotenuse. We only have the other two sides. So this is going to be tangent of our angle, 47, equals opposite over adjacent. So this is going to be x on top. So we're looking for information on the top now. So these three examples are going to take you through, show you how to do them for any of these situations. Angles, x on bottom, x on top. All right, and now the part where people sometimes get stuck. How do you solve them? Well, when sine is, or when what we're looking for is the angle, we are going to have to kind of use this reverse strategy of the inverse. So when you're looking for the angle, you change it to inverse. So it's the opposite. We're looking backwards. And since we know the ratio, all we have to do is type this into the calculator. In this calculator, you press second sine and then 14 divided by 15 in parentheses. And it tells us 68.96. So the angle is approximately 68.96 degrees. So that's it. That's all you do. When you are finding angles, when that's your goal, you use the inverse. All right. When x is on the bottom, we're going to solve this like a normal equation. So we need to get that x out of the denominator by multiplying both sides by x. So we have x cosine 32. Remember, this is a number, equals 5. And like anything, if you had 3x equals 5, you would divide by 3. We're going to divide by cosine 32 because cosine 32 is an actual number. So x equals approximately, that's what those mean. And we're just going to type this into a calculator. On Desmos, we're in degree mode, that's good. I'm going to click here and type 5 divided by, and then go to functions. Cosine is sitting right here. Hopefully you can see that. Under functions, and I'm just going to type in 32. 5.9. All right, so that's how it works in Desmos. The length of that side is approximately 5.9. So when x is in the denominator, this is the strategy that you will use. All right, and now tangent. X is on the top this time, and we're going to solve it like a normal equation. So we're going to multiply both sides by 8 to get it out of the denominator. So we have 8 times tangent 47 equals x. And now you just type that into your calculator. All right, so I'm going to use my phone calculator this time. I'm going to turn it to degrees. It says radians up there. Hopefully, we'll see by our answer what it is. 8 tangent 47. Nope, that one is in radians, so I guess it was already in degrees. There we go. So 8.6 is approximately the length of our missing side. All right. So those are an example of how you would do each one. Remember, this is not an example of sine as far as across the board. This is how you do a sine, cosine, or tangent when you're finding angles, when x is on the bottom, when x is on the top. All right, so I am going to now just talk about angle of elevation and depression real quick, and then this video will be over. Just a quick little talk about those two things. Angle of elevation angle of depression. So these are actually word problem situations, and you'll see them a lot. So you just need to be able to draw a picture and understand what it means. So for angle of elevation, I always think about like an airplane taking off or something. So you have your runway, and your airplane is coming, and then it takes off, and it goes like this, boop, 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 right? Your airplane takes off. So here's our airplane now up in the sky. Beautiful airplane. This angle right here is the angle of elevation. It's like takeoff. Now, is that the only situation it's in? No. If it's the difference, what it really is the difference between the ground and the trajectory or the path of an object. Sometimes it's like eyes, like you're standing here looking at something. And so the difference between looking straight ahead and looking up, that's the angle of elevation. And so when you're drawing pictures, just kind of picture that. That's the important angle right here. Angle of depression is the same idea. So you have an airplane or whatever, right? And it's flying straight, horizontal or parallel to the ground. And then it's going to go down to land on the runway. That angle is the angle of depression. It's the difference between looking straight ahead or looking down. It's that angle right up here at the top. But just a small, tiny drop of review from geometry class. If you're picturing the ground here, right, the ground and the flight path were parallel. And so the landing angle, the angle of depression, is also down here. And the reason that's important is because a lot of people like to use, like sometimes they'll say, how high up is the airplane? And while yes, you could look this way, most people are thinking of this part for how high up it is. So that angle is interchangeable because alternate interior angles are congruent. All right, I hope that was enough to bring back memories and refresh your memory. But if not, let me know and I'll help you.